In this video, we will explain the basics of machine learning and introduce the most important terminology. We will need this for the rest of this course. Let's begin with the detailed technical definition of machine learning by Tom Mitchell. The definition is: a system is said to learn from experience E with respect to some task T and some performance measure P if its performance as measured by P improves with experience E. This definition might be a bit overwhelming at first, so maybe you will have to read it another time. You can pause the video if you like. Let us try to apply this definition to the example of filtering spam emails. Pause the video and try to fill in what is the experience E, the task T, and the performance measure P in this case. When you're done, continue this video to see if you are correct. Okay, welcome back. Let's analyze the spam filter together. The experience E is the dataset of spam and non-spam emails. We also use the word examples to describe this dataset. These examples show the computer what should be considered as spam and what is normal. What is the task T? Our task is classifying whether an email is spam or not. The performance measure P is often the percentage of emails that were correctly classified. This is also called the accuracy. Or we can also look at how many mistakes our model has made. If you compute this percentage, this is called the error rate. So we have examples of spam and non-spam emails. We distinguish between these examples, also called objects, based on their label. In our task, the labels are spam and not spam. The label is indicated by the letter Y. It is the thing that we want our model to predict. Such tasks, where the objects are assigned to a category, are known as classification tasks. Let us now talk about the learning process. We start with a dataset of examples and their corresponding labels. We provide this to a learning algorithm. The learning algorithm will try to discover some rules. It will try to come up with what we call a model. Such models are usually governed internally by parameters. This is called the learning or training phase. In this phase, we are trying to find a good model. When we are done with training, we would like to measure if our model performs well. That is called the evaluation or the testing phase. In this phase, we get some new objects, in our case, new emails, that our learning algorithm has not seen before. We input these new emails into the model. The model makes a prediction for each email. Now we can see if the model is performing well. We compute the accuracy, that is the percentage of correctly classified emails. Note that the evaluation is always done on new and unseen objects that are not used during the training phase. Why? Well, because we want to find rules that work well in general. The rules shouldn't only work well on the training data. In other words, we want to build models that can generalize well to unseen emails. Good generalization, that is the ultimate goal of machine learning, and it is a positive thing. Do not confuse this concept with the concept of overgeneralization, which is usually associated with negative things like discrimination. To build models, we need a way to represent objects inside the computer. We do that by defining features, which we typically denote with the letter X. Features are basically a list of numbers that represent the object in the computer. In the case of emails, you can, for example, count how many times some words occur. Here we can see the different word counts for different emails. We can represent every email as a vector, a list of numbers designated by X. In case of the first email, we would get a vector of 100, 10 and 1. Now we have seen a case where the objects are already digital. Since they are already in our computer, we can easily extract features such as word counts. What if instead we are dealing with real objects? Say we want to classify apples versus bananas. How can we represent an apple in the computer? Well, what we can do is we can measure the features using, for example, a sensor. For a fruit, you can think of a weight sensor, a scale, which allows us to measure the feature weight. We could also measure color by, for example, taking a picture and by looking at the colors of the pixel. This way we could come up with a feature called greenness, which seems especially useful for fruit. This way we can represent a real physical object, like a fruit, in the computer. In this example we have two features. This means we have a two-dimensional classification problem. In machine learning terminology, we can say that D equals 2, or that the dimensionality of our data is 2. Now imagine that we have gathered the apples and bananas, we have measured their features, and we make this scatter plot. Now we are looking to find a model that can distinguish between apples and bananas. This will happen during the training phase. Our classification model will come up with a so-called decision boundary, such as the one indicated on the slide. On the top we have the bananas, and on the bottom left and bottom right we have the green and red apples. Okay, this was the training phase. Now let's talk about the test phase. In the test phase we would get a new object and measure its features. Afterward we can put it in the scatter plot and we can determine its label according to our model. We want our model to generalize well. This means we want the prediction for such an unseen object to be correct. Now you should realize one thing about features. Good features allow you to build a smart and accurate model. We can consider the weight and the color of our fruit to be good features, suitable for the task at hand. But there also exist bad features. For example, we could try to predict the type of fruit based on the time when it was purchased. This does not tell us anything about our object. Using such a feature would only introduce noise into our model. It should be considered garbage. You should be aware of a very important concept in machine learning, and that is called garbage in, garbage out. When you collect garbage features, then even a great and smart model will produce garbage results. Therefore, it is always important to choose or construct your features as well as possible. At this point, let us introduce another type of machine learning task, regression. Let's say you want to get in shape for the summer. Every day you measure your weight. Over time, you would like to see your weight decrease as pictured on the graph. Now say you would like to know how much time it will take to get below 85 kilograms. What can you do? Well, you can try to fit a regression model to this data and predict the trend. This is an example of regression. In regression, we also have examples, but instead of a categorical label, we want to predict a number. In this case, each object is a day, and it has a so-called regression target, the weight. The regression target we also indicate by y, and it is again the thing we want to predict. Okay, now what is inside a regression model? Well, it may look something like this. An equation y equals a times x plus b, where x is a feature. In this example, x could be the number of the day, for example day 1, day 2, etc., etc. A and b are the parameters, and they will be found during the training procedure. So our machine learning algorithm will try to find such an A and B that make our regression model perform well. Okay, let's summarize this video. We have talked about representing objects in a form understandable for the computer using features X. The number of features determines the dimensionality of our data D. In classification, we predict a label or a category. In regression, we predict a regression target, a number. We've also talked about the concept of a decision boundary and the different phases of building a model, the training or learning phase and the testing or evaluation phase. The most important concept that you should remember is the goal of machine learning. That is good generalization. This means we want our model to perform well on new and unseen data. Finally, we have talked about models and what is inside them, parameters.